Hey folks, hello. Today I'm going to tell you about black holes. Black holes. Ha 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 ha. Hello. So my name is Shlok. Today I'm going to tell you about black holes. Dark black holes. Dark and black holes. Today I'm going to tell you about black holes. Black holes. See, black holes.
अच्छा पामपुरी बोलता रहते मेरा पामपुरी
Black holes. When a star dies, a lot of epic stuff means a lot of weird stuff happens. Lot of weird stuff happens.
बाबा तुझे
Really, epic stuff happens.
आई बाबा
So much of, and it becomes a black hole or a neutron star or a white dwarf. If the star's core is less than 1.4 times the sun's mass, then it becomes a white dwarf. A really hot ball of super compressed matter about the size of Earth is a white dwarf, which can have a planetary nebula outside. A white dwarf. But if the core is heftier, so it becomes the neutron star. Neutron star it becomes. Really hot and intense gravity it has. It is also not less for a black hole. Neutron star. It happens when the star has less mass than 2.8 times the sun's mass. 2.8 times the sun's mass is Chandrasekhar limit. He was an Indian astronomer. Chandrasekhar limit, it's called. 2.8 times the sun's mass. But it stops the collapse because of neutron degeneracy pressure or electron degeneracy pressure, which stops the collapsing of the core. But if the mass is more than 2.8 times the sun's mass, then nothing can stop the collapse now. But which force can stop the collapse now? None. No force can now stop the collapse if the mass is more than 2.8 times the sun's mass. Nothing can stop the collapse then. As there is a particular velocity needed to escape some object from a particular gravity, which is called escape velocity. The Earth's escape velocity is 11 kilometers per second. The Jupiter's escape velocity is 50 kilometers per second. And the Sun, which is a more massive star, has a crushing 600 kilometer per second the escape velocity. When a rocket is 11 kilometer per second speed, it gone bloop, and it never falls back. But the sun's escape velocity is 600. It will fall back then, and the Jupiter's is 50 kilometers. The neutron star's escape velocity is a crushing half the speed of light, 150,000 kilometers per second. It's the size of 20 kilometers only. It's like a, a star, a hot ball which contains more than sun's mass in 20 kilometers across, which contains more than sun's mass. Now it's a neutron star, but when the collapse goes on, if the mass become if the size drops to more than it drops to 15, means it drops to like it when it drops to 18 kilometers, so it's a problem, because it happens that like the escape velocity is the light speed, which is 300,000 kilometers per second. Light goes, and nothing can travel faster than light. Not a rocket, nothing, not even light itself can travel faster than itself. And a black hole is formed. When the 2.8 kilometer is the Chandrasekhar limit. The core collapse effects make many things. Neutron, the sun, the math and physics of the black hole is really complex. It's named black hole because no matter can come out, so it's very a deep hole, and no light can come out, so it's black, so it's named black hole. It's totally dark. Its maths and physics is really hard, so many misconceptions happen. Do you know what is event horizon? Till where we can see the events, the region where events happen, and from there everything is beyond horizon. Earth's horizon is when we are at the beach, we see the sea at one end, it looks like the sky and the beach is meeting. It's the horizon, but event horizon is different, and where we see the black hole and the outer line go coming together, and after that we can't see anything. Bloop, gone. Like, oh, I am doing it like a black hole. This outer line is the event horizon. Event horizon. This is what an event horizon, and nothing can come out then. Even light cannot pass through. Like, here is a black hole, light coming inside and can't come outside. And now I was talking, some misconceptions happen, and one of them is the sun cannot become a black hole. It needs to be at least sun needs to get at least 3 times the current mass it has now to overcome neutron degeneracy pressure. That's why sun cannot become a black hole. And there is one more misconception. People think of black holes like cosmic vacuum cleaners. They think black holes are vacuum cleaners, cosmic. But it's not true. because the things which are clean means not the dust in the space vacuum, they suck everything. But I know the gravity is very intense of black holes, but only when object is too close to a black hole. Orbiting a 10 solar mass black hole is just like orbiting a 10 solar mass star. 10 solar mass means 10 times the sun's mass. A 10 solar mass black hole is what we say stellar mass black hole. Stellar mass black hole is the mass of sun. We use this like a unit tape to make comparisons and measure things. This is called, this is what the stellar mass black holes. You can, as any object can orbit a black hole till it keeps a safe distance from it, or you know the intense gravity of black holes. Oh, it can orbit, but if you get too close, gone inside because of the intense gravity of black holes. This is why black hole we can orbit. Stellar mass black holes are minimum 3 times the sun's mass. It has a minimum mass of 3 times the sun's mass. Stellar mass black holes, they are called. Stellar mass, like I said, means the sun's mass. We use like a tape to measure things, comparison. Huge. There was an idea proposed in 1970s, the first, that huge black holes can form in the centers of galaxies, and then very soon there was one found and in our own Milky Way galaxy, the Sagittarius A star. First, it was in the center of our galaxy. It was a supermassive black hole, actually. Supermassive black holes. It was. It was a supermassive black hole, and it is still. Now, it has a mass of 4.3 million times the sun's mass. And from that time, it's known like every galaxy has in its heart, and it may be crucial for the galaxy formation. The black hole, the star can blast away, the things explode and make the galaxies and all, and then become a shrinking core collapsing black hole. The closest black hole to the Earth's name is GAIAB-H1. Sagittarius A star is in the center of our galaxy. These are supermassive black holes. Do you know what is spaghettification? Spaghettification means if you imagine you fell into a black hole, feet first, say stellar mass black hole with having having a mass of 10 times the sun's mass. So what will happen? Feet first. The gravity on your feet will be million billion times stronger than your head. It will pull you like taffy. Here the head pulling you like a taffy. Fully you will stretch and stretch till a kilometers long, a long kilometers noodle, but narrower than a hair wide. You will be too small, narrower, and a noodle many kilometers long. It's spaghettification, like you will be pulled like taffy because the tidal force I taught in the 8th video. The tides inflict from gravity. And note, this is only for stellar mass black holes. If you fell into a stellar mass black hole, this spaghettification will happen in the milliseconds before it killed you already. Before you leave the known universe forever. Actually, I heard that if you are in a black hole, you will come out from a white hole. Don't know. This is spaghettification. This is only for stellar mass black holes, but supermassive black holes are far bigger. Billions or millions kilometers wide. And the distance between your head and feet will be too small for it. So the tides are not as much severe. But if you are falling from a long distance, you will be near the speed of light, and it can also take a fire on your clothes. This happens when you are falling into a supermassive black hole. Our Sagittarius A black hole is also a supermassive black hole. There event happened in 2011. One in a distant galaxy, a star got too close to the black hole in the center and was torn apart, disrupted, and when it fell into it, it blasted out so much of energy, like trillion times the sun's energy. And because of that only, in a black hole we could see the star going inside billions of light years away. In a black hole we could see it. It blasted us so much of energy and was then in the black hole. Oh, because in the black hole it was torn apart, fully disrupted, means cut by the tides. This happened. Albert Einstein has an idea that the universe is not just emptiness, full, empty, and all the planets, stars, black holes, neutron stars, supernovas. It's like an invisible fabric woven into the fabric, and it's like embedded. The more the massive the object is, the more it will go down. This is what happens. In the time slows down near a black hole. As you go near a black hole, it might be like here the 1 hour is 60 minutes. It can be 600 minutes at the black hole 1 hour. I don't know. The time slows down really. And at the event horizon touch, Your clock is ticking, 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 and the time stops at the event horizon. And then bloop gone inside. But when you're falling in a black hole, the outside who is far away can see you a little, and redshifted, gravitational redshift, a Doppler redshift happens. This is called at the black hole, and then you go inside the black hole, and you need that much light to come out, that much energy to fight the black hole's gravity, and you lose energy. Then this what happens. This all happens actually when you fall into black hole, and the perceiver which sees the clock, he sees it ticking, and when you hit go inside a black hole, while you are going, you see that the universe fastens up, and when you uh, touch the event horizon and go inside, all the time passes, all of it, and the outside observer sees your clock ticking slowly, and time is not same everywhere. It's woven into the fabric, the black hole, and it's tested on the earth by very intense clocks, but not near a black hole. This all happens. Thank you. We will meet next time. Bye bye.